material property overrides. Well, now it's called only material properties, but it used to be called override also. For those who doesn't know, quick, you can Google this and find all of it. But basically, it means like if you have float 2, float 3, or float 4x4, maybe there's other supported. I don't know. If you have a single one of these in a component, you can just add this attribute and name it something. And if you go to the shader where that's rendering the same mesh that this component is attached to, so the entity that's getting rendered with this crawler leg positions attached to it, that shader then will get access to this exact value through this name, like a shader variable. So dots with this property just say like, okay, here we have all of these components. Let's just copy them over to the GPU. And then the shader like, okay, I have, and there's instanced rendering, and they just can like pick out their respective data point in the array and just render all the entities with their respective component data just through this name. So what I do is that we can take a look here. Well, it's just further down in the same file, if I don't remember. So, and this isn't too much to read, but this is basically the crawlers. So this is all the crawlers, and they got a little bit of a dynamic buffer with the leg positions, and they got this leg crawler leg positions, an actual one component. I realize now this could also be just one component. It doesn't have to be a dynamic buffer, but that's a little bit legacy thing. The dynamic buffer can't be sent over to the GPU, so any dynamic stuff in dynamic sizes can't be sent over to the GPU that easily. So I think I started with this one with the dynamic buffer for the legs all the way, and then I sent it over somehow. But now it's done through this material property.
Okay,
so
cool.
I basically, the crawler is walking, and it sends out 4 different rays back and front, and it doesn't do it all the time because it's just only when it's like gets farther away, so it needs to like replace its foot.
Kind of like an
Then
IK solution almost, right?
Yeah. So it does some raycasting, and then it fills it in with the position of the leg. Well, it goes through all the legs here, so that's why it looks a little bit wonky. But this is the leg offset, which is somewhere here is a raycast. There is a raycast. So it finds the ground, and it's like, oh, this is supposed to be that's the place where the leg is supposed to be, and that's just a 3D position. There's no rotation to anything here. So I just fill in this wrong one, leg state. I can't even find my own code here. I just fill in there. So that's a 4x4. So that's XYZ for all the 4 legs, which means there's a row of W's that's not used because there's 4 legs and all of them uses 3, so only 12 values. So the W's, I don't remember if I do some metadata thing with them, but they are basically unused and doesn't matter. But there's no support for float 4x3 in the system, so I can't use 4x3.
That was going to be my question.
Yeah. I don't remember. Maybe there's a way around it, but I think it's more of a limitation in shader graph than anything. Maybe if I wrote it by hand, I could get access to it. Yeah. So if we now go into this thing, crawler. Now let's see if I can get this stuff to actually find my stuff. Let's open the crawler skin emissive, and we can take a look. The trickiest part about this is really to raycast, and because when you raycast, you get the world position of the raycast, right? Of the hit. But when you're rendering, when you're rendering the crawler, then you're then you're going to render it relative to the local to the world position of the crawler. So the offset from the crawler is the relevant part, not the world position. So you need to recalculate that to make sure that in the array is the local
The
position
local
of the
base, yeah.
foot relative
Okay.
to the crawler's world position. But other this is a fascinating resolution. Let's see if we can find anything going on here.
That is quite the complex graph you got going there.
This is nothing
That's
compared to
actually,
the parallax stuff.
yeah. Good point.
The parallax interior, that is a weirdly big one.
I'll get a
Anyway,
link to that, by the way.
oh yeah. So here we have the leg position, and this is where the magic happens. So this reference is the same name as the same name as what I wrote in the material override, and then you see here we get a full 4x4 size. And the only thing that really needs to be done here to make sure it works is to press this override property declaration and then specify hybrid per instance. That means that this graph will hook properly into the dot system and pick up that component array and pull that over to the GPU, so all the entities you're rendering have the respective component value available. So yeah, so and then then there's one way to pick this 4x4 matrix out. So this is how it's done. And then I just use that, and here it's super annoying. So this is super weird. So this is just one graph render, one execution. This is on the vertex, right? Vertex shader. So we're doing one vertex at a time, like any other vertex shader. So how do I know which foot when I'm supposed to read what position? Because the specific point on the specific foot vertex needs to be identified, and then read that position in the buffer and put that point on that spot, right?
Okay.
So I have the four different legs have each a unique vertex color, and that's a vertex color that's baked into the VFX.
To the
What's
like into the mesh, basically, or
yeah. FBX. That's
FBX. Okay.
Yeah. So that's baked into the FBX.
Oh,
and
cool.
then I split it up and I do some sort of math on it to make the value, the color value, into a easy digestible value, and then I have this comparison. So if the vertex color value is equal to 1, then I should read the first position in the first row in the matrix. If it's equal to 2, then I read the second, and I just and all of the rest doesn't read
smart
any
solution,
of the position. Yeah.
You
so
just
that's,
basically sample the vertex for what its color is, and then
yeah
do some basically logic to see determine if it is a foot, and if it's not, then I guess you just don't do anything different.
Yeah.
But then if it is, then you can set the position.
Yeah. So
Cool.
that's.
Did you
and
come
that's
up with
how
that yourself, or did you find that trick somewhere else?
No, I came up with that myself.
I like it.
Yeah, but it's gone through. This is not like, oh, I got an idea and then I program. This is like a year of it.
Banging your head against the wall. Like,
well, to be fair, like I implemented this in the built-in renderer through just normal code in the beginning, because
back when it was hybrid renderer V1.
Back when this game wasn't even HDRP.
Okay. Yeah.
So it was just completely just built in and just straightforward like that. And then it gone through a few iterations. It was once something called a structural buffer, where I send over the buffer explicitly through my own call, and then I sample that through code. But then I realized that that's basically the same thing that's going on right now. so I could just swap it out and use a float by 4x4 to capture. The thing was that in the beginning, the crawlers was supposed to have a variable amount of legs. So that makes it a little bit trickier. So the original code supported a variable amount of
It could be
legs.
like a spider with 8 legs or something.
Yeah, exactly. So that's how all of the enemies in Just Read Instructions is animated. All of them. All of them are animated by just on the vertex shader moving the vertexes.
That's cool.
There's no bones or anything. Everything is just completely math based. This is how like bones are made through similar ways. It's just a bunch of math with some vertex color data that says like, oh, this arm is part of this bone, and this,
Right, right. Yeah,
goes through a
makes
little bit of a
sense. Yeah, just
hierarchy.
basically finding ways to stuff in metadata to your existing data structures.
Exactly. So it's fascinating, and then when you realize that, and you if you have time and are a little bit weird like I am, you're like, I can make this myself in a different way and not have to rely on this generic bone structure. The bone structure, the one that like Blender spits out, that has a bunch of weird limitation and quirks that you need to deal with when you do it. So yeah, yeah, I have a Pac-Man animation where it's like a 3D Pac-Man that moves his mouth. That's completely math based also. That's like,
Sweet.
yeah, it's just GPU animated, and you can do so much with Shady Graph if you just go nuts with it.
That's super cool. That's super cool.
But
Actually,
I
real
can
quick,
just
we can hit this question. The player characters are animated with bones, though, right?
yeah, the yes. So I can show that real quick here. Cara that was right. Character animator. Oh, that was a little bit wrong. Let's see here if we can find our way back to the actual right thing here. My my computer is so slow right now. It's just barely shipping for air, doing all of this stuff at the same time. Anyway, there we have the start. So death animation update. So here we have a normal entity iteration. And you can see here is a bunch of first person camera, health, gameplay state. This is the old rival thing before it got integrated into Unity. So this is character controller component. That's Phillips is the name, right? His old stuff.
Yep,
I
yep.
haven't upgraded because yeah. And then we have player character, which just basically holds the reference to the animator and everything that needs to be. And then so for example, if we go here playing, then we just like pick up character body, relative velocity, local velocity. We send it into this update loop here, where we have all of this typical thing is grounded, yaw, local velocity, all of those things which affects how the player character is animated. And then we just push a bunch of them into the mechanism controller, and hopefully it animates properly. that's just ripped from Mixamo and just basic animated. And the arms are different layers. They are completely IK, so they
Oh,
follow
cool.
the
Okay.
that thing.
Yeah.
But the feet are just straight up simple Mixamo with some blending and some fancy stuff. Not really fancy, but yeah. So that's how the characters are animated, because that's not really a relevant thing to do in dots yet. There's no good reason for it. This is not a performance issue at all. Hope that answers the question.